Hello, my name is Mary Yen, and today we're going to learn about algorithms that match ads with you to enhance your web browsing experience. But let's back up for a second. Why do advertisers plaster their gorgeous ads all over the internet? What does the internet offer that tried and true methods don't? The internet offers the biggest audience for advertisers. They can go national. They can even get international. The bigger the pool, the more fish to catch, right? Wrong. We've got to be smart about this. We have to target a specific audience, and the internet makes it easy to do just that. We can specify where and when to display the ads, select sites relevant to the product, and find specific user bases. So we'll note that there are three players: the users, you guys, the platform, such as a search engine or website, and the advertisers. Users want/should look at ads relevant to them, and the platform wants to get revenue from offering the ad space. And the advertisers want more exposure and more sales. So platforms offer suppliers ad space, and advertisers will bid on these spaces. But how do platforms know what's the best ways to match an ad space with ads? So here's the setup. The ad allocation algorithms will help us on a basic level. We can have the ads be represented with a set U. And in this space, we will have a bunch of nodes that represent each ad. And similarly, we can represent available ad space with a set B. Each ad comes with a contract that specifies what kind of space it's looking for, such as a display time or size. If an ad space matches the specifications, then we have an eligible space. We can put an edge between any ad and space nodes that are eligible. And we can only match nodes that are eligible. As we see from that red line, those are a couple of matched nodes. Note that we also can't put edges between nodes that are both ads, since ads aren't eligible for ads. Same thing for the space. And to simplify our problem, we also won't allow ads to match with more than one space and vice versa. And this setup will be called a bipartite graph. An ad allocations algorithm is to match as many eligible ads and spaces as possible. This is called the maximum matching. To start, I can just go through the nodes on one side and match them with the eligible nodes on the other side. This isn't exactly the best solution. We'll notice that U4 and V3 aren't matched. Is there a way to do better? Here's a quick shortcut. First, we can find an augmenting path, which is a path that starts with an inactive edge, and then it alternates to an active edge, and then it must end with an inactive edge. And by Burgess' theorem, we can flip the activeness of the edges on this path to get the maximum matching. But why does Burgess' theorem work? Starting and ending with a non-active edge while alternating in between will ensure that you increase the number of active edges and therefore the number of matchings. For ad matching, we're dealing with what we call an online input set, as opposed to an offline set where we have all the information and nodes from the beginning. The online set models how space becomes available one at a time. When an ad space loads in a user's browser, this space needs to be assigned immediately because users just don't like waiting for anything. We also can't change any of the matches once we've loaded them to the browser. So how are we going to find the maximum online matching? There's actually no way to find the optimum maximum matching, so the best we can do is use a greedy algorithm. And being greedy means that you just grab whatever is immediately available to you at any time. So we'll start with V1, it just matches with U4. V2, so let's just match it with U3, and so on. But we'll see that we didn't really get to pair all the nodes. So how do we actually know if a greedy algorithm is good? We measure greedy algorithms by measuring the competitive ratio, which is the ratio of the greedy online performance to the optimized offline performance time. And now that we know the basics of ad matching, let's take a look at how bigger companies can modify the algorithm to be even more profitable. So let's take Google, for example. The majority of its revenue comes from ads displayed on user search queries. This means that each time someone makes a Google search, a new ad space is up for grabs. Google introduces another layer to the ad space eligibility. It requires that advertisers bid for each ad space. In a simplified form, each advertiser's bid is the monetary bid multiplied by a quality score. The quality scored is determined by the ad's click-through rate, the ad landing page quality, and the keyword relevance, amongst various other factors. In this way, Google arranged for ads that are more relevant to users to display for less money, and therefore to enhance experience for both the user and for the advertiser. So let's do a quick recap. Online ads have 3 players to optimize for: the user, the advertiser, and the platform. The platform optimizes revenue and experience by performing an online bipartite matching with ads and ad space. And then companies can add bidding and other factors to bipartite matching to increase revenue and viewing experience. So there's a lot going on behind the scenes of these wonderful ads, which are optimized for your viewing pleasure. Thanks for your time.